Hello students, welcome back. Now let's go to section 2 and work out some exponential and logarithmic equations. First, some exponential equation problems here. Please note that they are all natural exponential equations. We're going to consider arbitrary basis sometime later. First, a little bit more important of the two, the natural exponential equations. We're going to focus upon two types of exponential equations. First, quadratic equations, and second, linear equations of logistic form. Which is easier, quadratic or linear? Well, most students will say linear equations are easier, but in exponential problems, most students find quadratic equations easier. Let's go ahead with quadratic problem first. Okay. Here is an exponential equation, and we are looking for x value. And let's put some space in between. Now, did I say this is quadratic? It'll turn out this is quadratic because this is e to the x power as one entity, and this one, e to the 2x power, regarded as e to the x power squared. So I just rewrote e to the 2x power into the e to the x power squared. Now this is a quadratic equation of e to the x. How to solve this? 2 e to the x power minus 3 to e to the x power minus 1. Is that it? 4, 2, negative 6. I think this is it. Not sure, then you can always do this. Oops. Sorry, wrong key. I have to restart. Insert. Okay, a tic-tac-toe board. 4 times 3 is positive 12. First times last. Factors of positive 12 adding up to negative 8. So we need negative 2 times negative 6. Agreed? So they multiply into positive 12, and then they add up to negative 8, the middle coefficient. And then let's fill these out. 2 times 1, I did negative 1. And then 2 times negative 3. Does all computation, all multiplication work? 2 times 2 is 4, negative 3 times negative 1 is 3, 2 times negative 1 is negative 2, 2 times negative 3 is negative 6, all good. Cross multiply, 2 negative 3, okay, that's here. And 2 negative 1, that's there. So cross multiply, we get this. Okay, now that we have this, let's go ahead. 2 e to the x power minus 3 is equal to 0. Or 2 e to the x power minus 1 is equal to 0. From the first, we get 2 e to the x power is equal to 3. In other words, e to the x power is 2 over 3 if I divide away. Two e to the x power is equal to 1. So if I divide away by 2, that's 1/2. All right, but then again, that's not the end of the problem. we want to find out x, but we found out e to the x. How do you get x from e to the x? By taking the natural log of both. Natural log of e to the x is natural log of 3/2. That comes from, let's do the color coding, blue. So that's blue equation, that's blue, and that's blue, yeah. And consequently, cancellation, log and exponential cancel out, x is log of 3/2. And what is log of 3/2? You can calculate it out to your calculator if you do it right. 0.450 something. That's what you're going to get. Check it with your calculator. But then again, how about this? Maybe this is equal to 0. Red factor is equal to 0, so that we get red equation. E to the x is 1/2. From there, again, let's take log of both sides. E to the x power is log of 1/2 if you take log of both sides. And left hand side, we have cancellation. Log and exponential cancel each other out. We just get x. And then right hand side, log of 1/2. And that's the answer, yes. But if you're a little bit unsure, or if you want to see how large it is, punch in the calculator and do your computation. You're going to get something like this. That comes from the red factor, and we get two solutions. X can be either log of 3/2 or x can be log of 1/2. Both are valid solutions, and the numerical values of those valid solutions will be either 0.405 something or negative 0.969 something. Either way, it'll work out. Let's see, what did I do in my answer key here? Factor it out, we get those, and then taking the log of both sides, we get these. Okay, other than the color coding, it's exactly the same idea. Ready for the next problem? Okay, let's do this. Okay, how do I work this one out? Let's put some space in between. And e to the x power. And here I can rewrite as e to the x power squared. So this is a quadratic equation. And then you can factor like this. 2e to the x power minus 3. No, I think it's plus 3. E to the x power plus minus 1. Let's see. 2. No, that's not right. Minus 1 plus 3. 6. Okay, all right, that's the right factorization. And as for tic-tac-toe method or whatever, I'll leave those to you. So what do we have? We have blue times red is equal to 0. So one of them has to be 0, right? So from the blue factor, 2e to the x minus 1 is equal to 0. 2e to the x power is equal to 1. E to the x power is 1/2. Now taking a log of both sides, log of e to the x power is equal to log of 1/2. Oops. But then again, log and exponential cancel each other out, right? So we just get x equals log of 1/2. Looks like there goes the solution. And do you remember how large it was? Yeah, 0.69 something. I calculated before for the previous problem. Anyway, we have a solution from the blue vector. Okay, all right. Blue times red is equal to 0. Blue is equal to 0. That gave me this. How about the other? E to the x plus 3 is equal to 0. And that's coming from this red vector. So what do you get? E to the x power is -3, and clever student must have found out something already. Exponential can never become negative. Remember the definition? And basically we have repeated multiplication. So here's a graph of e to the x power. It's always above the x-axis, always strictly positive. It'll never take a negative value, so already things are going wrong, but assume that you didn't catch it yet. Take the log equals log of -3. So log and exponential cancel each other out, so we have x equals to log of -3. And let's assume you still didn't catch something was wrong, because inside of the logarithm cannot be negative. Here is the graph again. Previously, exponential is always positive, you could see. And here, inside of logarithm, always positive. So already we have strike 2. Actually, 2 outs rather. Suppose that you still didn't catch. Punch in the calculator. And you get something like this. We ended up with a complex number. That's Mathematica, because Mathematica is based upon complex numbers. For handheld calculator, it's going to be just straight up error message. So what is this? Invalid. Extraneous, or whatever term you may want to call it, illegitimate. So we have blue factor times red factor equals to 0. It turned out blue factor equal to 0 is okay, and we got a legitimate solution. X equals 1/2. X equals log of 1/2, excuse me, and it has this approximate value, -0.693 something something. The number itself is not that important, but the existence of this numerical computation tells you that this is valid. Now, red equal to 0, we get exponential equal to -3. Already that's invalid. Exponential is always strictly positive. But if you didn't catch it, take the log of -3, and that's another red flag, because inside of log always has to be positive. But let's assume you still didn't catch it. Punch in the calculator, you get an error message, or even if you're lucky, you get a complex number. That's invalid. So that doesn't give you any solution. We just have one solution. What did I do in my answer key here? Yep, pretty much that, and the same conclusion. Okay, that's how you can solve a quadratic equation. When you come back, we're going to deal with some a little bit complicated expressions with some denominators to work out. See you soon.